Hi everyone, this is Professor Sargent. In this video I want to clear up something that may be a little confusing, the way we graph inequalities. Okay, so hopefully at this point you've read the text about solving inequalities in interval notation and watched the videos about solving inequalities and putting them in interval notation and graphing the resulting set. And you may have noticed a difference between the book and the videos, and that's what I want to talk about, the way we graph inequalities. Okay, so take this problem number one. We want to solve, we want to put in interval notation, and we want to graph it. So it's a very basic one. The point of this is to really touch on the notation and the graphing. So let's go ahead and solve it. X minus 3 is less than or equal to 1. So of course what you would do to get x by itself is add 3 to both sides. And we've solved the inequality. Okay, x is less than or equal to 4. That's all the numbers. That's the set of all numbers that are less than 4 but could also be equal to 4. All right, so we've solved it. If we want to put that in interval notation, starting at the smallest number, which is everything less than 4, so it goes all the way to negative infinity. So we start on the left with the smaller, and we go up to the largest number in the set, which in this case is 4. And because we have less than or equal to, we include that 4 in our solution set, so that gets a bracket. That shouldn't be new. That's in your text and in the videos. Okay, the instructional videos in your Blackboard course. All right, now here's where things are a little different, and this is what I really want to explain how to graph that. So we solved, check, we wrote it in interval notation, check, and now for the graph. All right, so let's say we have an empty number line, 0, 1, 2, 3, 4, 5. Okay, and going back, -1, -2, and so on. Okay, so you're given these, and you have to graph this set. Okay, so here's what the book does. They say let's shade all values that are less than 4, +4, and include 4, and they do the same thing that interval notation does. They will use a bracket if that 4 is included and shade all the values that are less than. That's the answer. That's the graph of that. But if you watch the video, they did it a little bit differently. They did not use this bracket right here. Instead, they used the circle system. Okay, so instead of a bracket, let me draw the same set or the same graph. 1, 2, 3, 4. Right? We're still shading all the values that are less than 4, and we want to include that 4 as our endpoint. But instead of using the bracket that says include, we use a circle. Okay, and if we're including the endpoint because of the underscore here, then we fill in that circle. Okay, so this is what they do in the videos you watched and what you'll have to do in my Open Math. It's the circle system. In this example, we've just seen the closed. I'm going to talk about the open circle in a second. And this system is what the author of your textbook used. Okay. The interval notation is common to both. This is for both. This is for both. The only difference is in the graphing piece. Okay. So the textbook used the bracket and parenthesis system, which I'll use in a second, and my Open Math, and also the videos, when he graphs them in his videos, instructional videos, he does the circles as well. Okay, so let's just run through a couple more just so that's clear. So let's pretend like we just want to graph. So you have the interval notation, and I just want to graph the following set. So let's go from -1 to infinity. I just want to graph it. Let's say we already solved. Remember, that would be equivalent to a solution of all values x greater than -1. So say we already solved and we got all values x greater than -1. This is interval notation. Okay, that piece hopefully you already learned, or at least you read about, watched the videos. And now the graph. And the reason really I'm making this video is because in your textbook it'll be graphed one way, In my open math, it'll be graphed a different way. All right, so it's best to know both ways, right? Because when you take future math courses, you might see either one, so it's best to know both. So this is what you'll have to do in my open math, and this way it'll be in the textbook. Okay, so we're gonna do two graphs. They represent the same set, the same solution, but I just want to show you the difference. So there's 0, 1, 2, 3. Okay, 0, 1, 2, 3. Okay, so this says all values starting at -1 and going to positive infinity. So I'm going to graph that. So in the textbook, they would use a parenthesis to not include, because the -1's not included because there's no underscore here in the greater than symbol. So it's everything above -1, not including -1. So that's all these numbers here that I'm shading, right? All these values going here forever. So that is the set. That's the graph solution. So how would you do that when you do your online homework program in My Open Math? Well, it's the same exact set. You're still shading all the values here, everything going that way. But instead, you'd have to select the tool that is the open circle. Okay, so one way to summarize to connect what's in the textbook to what you have to do in My Open Math is that an open parenthesis is the same as an open circle. Okay, or parenthesis is the same as an open circle, and a bracket would be the same as a closed circle. Okay, and that would also be true if it's opening this way or if this guy's opening that way. Okay, so different notation, but again, best to know both. So I hope that helps.